We're going to take a look at a couple examples of absolute value inequalities and solving them. So there's really two types. There's going to be an AND type and there's going to be an OR type. They both involve compound inequalities. So for example, if I have absolute value of x is less than 5, remember absolute value is distance from 0. So we want to live within 5 units of 0. So we don't want to go further than 5 to the right and negative 5 to the left. Okay? So no further than 5 to the left and 5 to the right. So that bounds us between negative 5 and 5. Inequality, that looks like negative 5 less than x less than 5. And an interval that is negative 5 to 5 with parentheses. In general, for some c in the positive real numbers, it's the same thing. If x is less than c, that implies that negative c less than x less than c, or in the interval notation, that means x lives between negative c and c. Okay? Alright, so let's do an example where we solve one. So let's say we have absolute value of x plus 5 is less than 4. So where the absolute value in the interior is equal to 0, that's at negative 5. So the absolute value of x plus 5 is measuring the distance between x and negative 5. We want that distance to not exceed 4 units. So we don't want to go further than negative 9 to the left, and we don't want to go further than negative 1 on the right. But let's go ahead and do the math to show that. So this is an AND statement, so we don't want to go, we want to be bounded between negative 4 and positive 4. And what we're going to do is we have 3 sides of an inequality, so anything we do to one side of the inequality we do to all 3 sides. So we have negative 9 less than x less than negative 1 as an interval, start at negative 9, end at negative 1. And if I draw in my number line, I'm going to put in all the points. And we're going to be from negative 9 to a negative 1. Now let's say, because I claimed that x plus 5 in absolute value measures the distance from negative 5. So here we are standing at negative 5. To go to negative 1, I'd have to travel 1, 2, 3, 4 units. And I didn't want to exceed 4 units in the original problem, so that looks good. Or if I go 1, 2, 3, 4, I don't want to exceed 4 units, so I get all the way out to negative 9. So that's what it looks like on the picture. Okay, so that's an AND. And remember, we're required intersection, and then if we have this compound inequality right here, we have that x plus 5 wedged between a minus 4 and 4. That's going to be an AND statement. It's going to most likely be something compact like negative 9 to negative 1. Well, not quite compact, but a small little bounded set. Compact is something other. Never mind. Alright, so the other case is the absolute value, for instance, is greater than 5. That means we would like the distance from 0 to be greater than 5, so maybe, you know, there's a stinky factory or something like that at 0 that's putting out a lot of smog or whatever, or chemicals and stuff, and we want to live at least 5 miles away from it. And maybe we can only go east or west or something like that. I don't know. We can just make something up. So we would need to be at least 5 miles to the east or 5 miles west. So in one direction that'd be greater than 5, in the other direction that'd be less than negative 5. Okay, and we have 2 pieces, so we have to go from negative infinity to negative 5, and then we have a union to jump over, which means OR. So we don't want to be in this stinky area around the 0, and then 5 to infinity. Okay, so let's do an example where we actually solve something. So absolute value of 2x minus 3 greater than or equal to 7. So on one hand, we would like to be greater than or equal to 7, or we would like to be less than or equal to minus 7. So that's either further further to the east or further to the west as my two inequalities there, so that we're away from this stinky factory, and this stinky factory would actually be at 3 halves as opposed to 0. Okay, we're going to solve both inequalities in the same way. We're going to add 3 to both sides. And then we'll divide both sides by 2. So we'll have x is greater than or equal to 5, or x is less than or equal to -2. So that's an or we don't need both. We don't need intersection. And there we either live east or at -2, not east, west of -2 or at -2, or we live at +5 or east of 5.